Welcome to the second lesson of the 6th chapter in the Pearson Geometry Lecture Series. This lesson covers 3 concepts: properties of kites, properties of isosceles trapezoids, and finding midsegments of a trapezoid. In Lesson 6.1, we used what we know about triangles to find angle measures of polygons. In this lesson, we'll use what we know about triangles to develop properties of quadrilaterals. Let's start with kites. Theorem 6.3 says that the diagonals of a kite are perpendicular. But wait, there's more. Look at example 1. Right here, we have our perpendicular lines, and this is QS, a perpendicular bisector, which means that TP and RT are also congruent. Since TS is congruent to itself, then we can say that these 2 triangles are congruent because of side, side, side. And likewise, since QT is congruent to itself, then we can say that these 2 triangles are congruent also by side, side, side. So we can break a kite up into 2 sets of congruent triangles. So what is the measure of angle 1? All 4 of these are going to be right angles. So that means the measure of angle 1 is 90 degrees. What is the measure of angle 2? Well, since this is a right triangle, and 90 plus 35 from 180 is going to give us angle 2, then we can go ahead and subtract 35 from 90, and that's going to leave us with 55 degrees. So the measure of angle 2 is 55 degrees. Finally, the measure of angle 3 is going to be the same as this measure of QPT, because these 2 triangles are congruent, which means that the measure of angle 3 is going to be 35 degrees. All right, we will come back to example 2 in a little bit. All right, let's take a look at Theorem 6.4. Theorem 6.4 says both sets of base angles in an isosceles trapezoid are congruent. Okay, first of all, what is an isosceles trapezoid? Here we have 2 trapezoids. This is a regular trapezoid. This one, like an isosceles triangle, has 2 sides that are the same. Those are congruent. That makes it an isosceles trapezoid. And the base angles of an isosceles triangle are congruent. So in an isosceles trapezoid, both sets of base angles, as in this set, are congruent, and this set are congruent. So angle A is congruent to angle D, and angle B is congruent to angle C. We can use that later to solve problems. Okay, now finally let's take a look at Theorem 6.5. Theorem 6.5 says the diagonals of an isosceles triangle or an isosceles trapezoid are congruent. That means that AC is congruent to BD. All right. Look at example 3. Using all the properties of isosceles triangles and therefore isosceles trapezoids, what is the length of ED? Okay, we're given a lot of information. We're given that EG is 21 feet, which means that, according to Theorem 6.5, DF is also 21 feet. That doesn't help us find this length right here. Okay, we also know that angle DGF is 77 degrees. That means that GDE is also 70 degrees, but also does not help us find the length of ED. However, we have FG broken up into 2 congruent parts. Each of them is 8 feet. And ED is broken up into those same congruent parts, which means that each of these are also 8 feet, which means that ED is equal to 16 feet. Okay, let's flip this over and take a look at Theorem 6.6. Theorem 6.6 says that the midsegment of a trapezoid is base 1 plus base 2 divided by 2. All right, let's back up. What's a midsegment? A midsegment is a segment that goes from midpoint to midpoint. And since both of these are midpoints, that means that it breaks up this side into two equal parts. Now, if that's an isosceles triangle, like it was in example 3, then all 4 of these parts will be congruent. This one does not appear to be an isosceles trapezoid, which means that these two sides will be congruent, these two sides will be congruent, but not necessarily to each other. So this is our midsegment. Since x and y are both marked as midpoints, that means that BC is base 1 and AD is base 2. Now, the reason that we can't just use the bases is because this base is too long and this one is too short. This one's going to be right in the middle. So if we add these two together and divide them by 2, like in theorem 6.6, what we're actually doing is averaging them. Now, sometimes you can do that in your head. So take a look back at example 2. Okay, in this first trapezoid, base 1 is 21, base 2 is 41. What's in the middle of 21 and 41? Well, right in the middle of 21 and 41 is 31. Okay, now if that didn't pop out to you right away, then look at it this way. 21 plus 41 is 66, and half of 66 is 31. All right, now in the second example, 18 and 48 are not quite as easy numbers to work with. So if we add those two together, then we're going to get 18 plus 48 is equal to 66, which means that x is going to be equal to 33. Okay, this last one is a much more complicated example. And that one is also back here on the other page. So let's flip this back over. The first part of example 4 is pretty textbook. So we've got 54 and 33. So 54 plus 33 is going to be 87. When we divide that by 2, we're going to end up with 43.5. Okay, the second part is a little more complicated, and we're going to take a closer look at this in class. Okay, let's go to example 5. In example 5, we're going to use theorem 6.5 that says that the diagonals are congruent. So what I want you to do is to pause the video, set up an equation that uses that property of diagonals in an isosceles trapezoid, and solve for C. Then continue the video and check your answer. Okay, so if you set this up correctly, you said 6c minus 5 equals 4c plus 3. Subtract 4c from both sides, and we get 2c minus 5 is equal to 3. Add 5 to both sides, and 2c is equal to 8. Your final answer should be c equals 4. Is that what you got? Well, let's try it again in example 6. Pause the video, set up your equations, and solve for A. All right. If you set it up correctly, you said 2a minus 1 equals a plus 13. Subtract a from both sides, and a minus 1 equals 13. Add 1 to both sides, and a is equal to 14. Okay. Example 7 can be worked out. Should be very familiar. When you get finished, check your answer in the upper right-hand corner of your notes, because that's going to be the same trapezoid. All right. One more thing. Before you go, do this review exercise. Match the triangle line segment to the correct point of concurrency. And then we're going to check these in class. That's it for now. See you later.